So question 3, working with vectors, it says find the direction of the vector in standard position with the endpoint 4, 5. So standard position, basically what this means is the positive x-axis is what's called standard position. So we have this here going on. So this is standard position. So the positive x-axis is. Now, our endpoint is at 4, 5. So if we plot the point 4, 5, 1, 2, 3, 4, and at 5. 1, 2, 3, 4, 5. Looks like about here. 1, 2, 3, 4. So the tail of the vector is at the origin. The head of the vector is where the point is. So forgive me, I can't draw it perfectly here, but so this is going to be our 4, 5. So a lot of times the magnitude, they'll use the letter R for magnitude. And direction is how far we rotated off of the x-axis. So the direction would be how many degrees off of the x-axis did we rotate. So a lot of times they'll use the Greek angle, the letter theta, the Greek letter theta for that. Now again, what I can do is construct a right triangle here. So in a right triangle, if this is the right angle, notice that if theta, again, let me make this a little bit closer. I got that kind of too far out there. So theta is out here. So if I want to find angle theta, if you will, in a right triangle, we have what's called SOHCAHTOA. So if this is the angle we're talking about, notice how what we know is this distance here is 1, 2, 3. I didn't even draw that right. I'd go in 5 out there, not 4. So try that again. 4, 1, 2, 3, 4. And then 1, 2, 3, 4, 5. So 4, 5 would actually be here. So if I draw my vector going out to that spot, that'd be more like 4, 5. So if I bring this down, so notice that if I create a right triangle, I have to forget my drawing there, but we have a right triangle here. Notice that the length of this side is 4, and the length of this side is 5. So if I'm using trigonometry, notice that if angle theta is here, the 5 is the opposite, the 4 is the adjacent, and the R, the magnitude, would be the hypotenuse, just like we did in the previous question. The magnitude would be the R. Now, this problem, though, we want to know the direction. So we want to know how many degrees off of the x-axis we rotated. Well, just based on my look, I know it's got to be under 90 degrees. So it's an acute angle. Now, since we have opposite over adjacent, that tells me to use tangent. So the tangent of an angle is going to equal the opposite over the adjacent. Now for us though, notice that x1 is actually the adjacent and y1 is actually the opposite. So in other words, x and y. So notice that the x coordinate is the adjacent and the y coordinate is the opposite. So I could modify this formula to say that the tangent of theta is equal to y over x. Now remember, to find theta, we have to actually use the inverse tangent. So theta is actually going to be the inverse tangent of y over x. So if I use that math, this formula here, it'll allow me to find the angle. So for us, theta is going to equal then the inverse tangent. Instead of saying opposite over adjacent, we just say the y coordinate over the x coordinate. So we say 5 over 4. Now remember, to find the angle, we have to make sure we're in the correct mode because they want us around 2 degrees. So if I turn my calculator on, if I go to mode, I am in degree mode. And they want us to round this to the nearest hundredth of a degree. So to do this, we can quit this. if we go inverse tangent, so I have to hit the second button, tangent, that gives me this inverse tangent symbol. And then in parentheses, we can put the 5 divided by 4, if you will, the y over x. If I hit enter, it should kick out the angle. So 51.34, 51.35. It looks like this is going to be 51.34. So theta would be then 51.34 degrees. So that would be our solution. So notice how with vectors, we are using a little bit of trigonometry to solve for the angle. So this is going to be our formula to find the direction that the vector is traveling in. So we weren't asked to find out how long it was, but we do know that this vector is traveling at at an angle of 51.34 degrees off of the x-axis.